show that the following are irrational numbers. So in the first question we have root 3. So let us check how to prove that given root 3 is an irrational number. On the contrary, let us assume root 3 is rational. So if root 3 is rational number means then root 3 can be able to written in the form of p by q. So root 3 is equals to p by q. But our textbook is following a by b. So that is the reason p by q I am replacing with a by b. Of course you can write p by q also, no problem at all. Then what is the condition for these rational numbers? A comma b both belongs to integers, b not equals to 0, and one more condition we need to write, that is a comma b are co-primes. So whenever you are going to solve this kind of questions, that is root 2, root 3, root 5, root 7, root 11, root 13 like this, so you need to do squaring on both the sides. So for this question, squaring on both the sides. So then it will become root 3 whole square equals to a by b whole square. Here square root square both will get cancelled. Then we remains with 3 equals to a by b whole square is nothing but a square divided by b square. Now take 3 to the left side. Here it is division. If you take another side, it will become multiplication. So 3 into b square is equals to a square. Write this as equation 1. Now take 3 to the right side. Here it is multiplication. If you take another side, it becomes division. So finally we will get it as b square equals to a square divided by 3. So now here if we observe this right side part, a square by 3, this a square by 3 can be written as 3 divides a square. Then if 3 divides a square, then 3 divides a also. 3 divides a. That can be written as a by 3. So if 3 divides a, then definitely it gives some answer, right? So that answer I am making equals to some constant c, because we don't know that answer, right? That answer I am equating to some constant c. Now take this 3 to the right side, then we will get a equals to 3c. This is equation number 2. Now observe the first equation. In the first equation we have 3b square equals to a square, right? 3b square equals to a square. 3b square equals to a square. But in the second equation we got the a value as 3c, right? So 3b square as it is. Here in the place of a I am substituting 3c whole square as it is. So we will get 3b square is equals to 3 square 9c square as it is. Left side and right side we can check for the cancellation. 3 1s are 3 3s are. Then finally we remains with b square equals to 3c square. Now take this 3 to the left side. If you take to another side, it becomes a division then. So b square divided by 3 equals to c square. Now here b square by 3, nothing but 3 divides b square. If 3 divides b square, then 3 divides b also. Now observe the previous statement which we got here. 3 divides a. And here 3 divides b. So we can conclude one thing, that is 3 divides a and b. A and b. So it contradicts the fact that a comma b are co-primes. Because in the beginning we took the conditions. In that one of the conditions is a comma b both are co-primes. It means for a and b only number 1 is the common factor, no other common factor. But here we got clearly that 3 divides a and b. So 3 is a factor of a and b. Otherwise 3 is a common factor for a and b. So that is the reason it contradicts the fact that a comma b are co-primes. So we can say that root 3 is a irrational number. Next, coming to the second question. 1 divided by root 3. Only for the first one, a little big process will be there, but remaining all the questions, it will be easy only. So now prove that or show that 1 divided by root 3 is an irrational number. First statement is as usual. On the contrary, let us assume 1 by root 3 is a rational number. So if it is a rational number means definitely we can able to write it in the form of a by b. So 1 by root 3 is equals to a by b. The conditions are a comma b belongs to integers, b not equals to 0, a comma b are co-primes. Now whenever if we having this 1 by root 3, 1 by root 5, 1 by root 7, 1 by root 11, this kind of questions, simply do the reciprocal. Now both sides of the equation I am doing the reciprocal. So 1 by root 3 reciprocal is root 3 by 1, which is equals to a by b reciprocal is b by a. Now still if we simplify this further, here root 3 by 1 can be written as simply root 3. That is equals to b by a. Here we wrote the condition clearly, a comma b both belongs to integers, right? So as a comma b are integers. Now once observe this right side part. Here right side we have b divided by a, right? So in the place of a or else in the place of b, whatever the number I substitute from the integers, then always this right side part will be a rational number only. So as a comma b are integers, RHS is rational. But if you observe this LHS part, that is root 3. LHS is root 3 and that root 3 is irrational number. But LHS is an irrational number. Here if you observe this clearly, right side part is rational number and left side part is irrational number. Both are completely not at all equal to each other. So this contradiction has arisen. This contradiction has arisen due to our wrong assumption. So 1 by root 3 is an irrational number. Next, coming to the question number 3. Show that 2 plus root 3 is an irrational number. First sentence as usual. On the contrary, let us assume two plus root 3 is a rational number. So if it is a rational number means we can able to write that in the form of a by b. So 2 plus root 3 equals to a divided by b. Conditions are a comma b belongs to integers, b not equals to 0, a comma b are co-primes. Now if we observe the left side, 2 plus root 3 equals to ab, right? So simply take 2 to the right side. If we take this 2 to the right side, then it will become minus 2. So root 3 equals to a by b plus 2 becomes minus 2. Root 3 equals to a by b minus 2 can also be written as 2 by 1. Now here both the denominators are different, right? So let us go with the cross multiplication method or else LCM method, you can say. Root 3 equals to b into 1b, a into 1a minus 2 into b, 2b. So root 3 equals to a minus 2b divided by b. Now same like the previous question, write the final statement as a comma b are integers. right? In the place of a and b, if you substitute any integer, always this right side part will be compulsory a rational number only. So as a comma b are integers, RHS is rational, but LHS is, now in the LHS we have root 3, right? Root 3 is an irrational number, but LHS is irrational. This contradiction has arisen due to our wrong assumption. Next, coming to the question number 4. Two plus 2 root 3. First statement is as usual. On the contrary, let us assume two plus 2 root 3 is rational. So 2 plus 2 root 3 equals to a by b. The conditions are a comma b belongs to integers, b not equals to 0, a comma b are co-primes. Now here, whatever the step we have, I am writing that again here. 2 plus 2 root 3 equals to a by b. Now taking this 2 to the right side, so that will become minus 2. So remains with 2 root 3 equals to a by b minus 2. This 2 can also be written as 2 by 1. So the left side part as it is 2 root 3 equals to, here right side we will be having different denominator side. So let's go with the LCM or else cross multiplication. B into 1 b, a into 1 a minus 2 into b 2b. Now from the left side this 2 also I am taking to the right side. So we will remains with root 3 equals to a minus 2b divided by this 2 I am taking to the left side, right side, right? In the left side it is multiplication. If I take to the right side it becomes division. So 2b. Now same like the previous two questions, last sentence as usual. As a comma b are integers, RHS is rational, but LHS is irrational. This contradiction has arisen due to our wrong assumption. So we can say that 2 plus 2 root 3 is an irrational number. Next, coming to the last question. Show that or prove that root 2 plus root 3 is an irrational number. So the first statement is as usual. On the contrary, let us assume root 2 plus root 3 is rational. Then root 2 plus root 3 equals to a by b. The condition a comma b belongs to integers, b not equals to 0, a comma b are co-primes. Okay, now this question where both the numbers are having square root, then for this squaring on both the sides is compulsory. So root 2 plus root 3 whole square, root 2 plus root 3 whole square equals to a by b whole square. Now if we observe this left side part clearly, root 2 plus root 3 whole square is in the form of a plus b whole square. So let us expand it. A plus b whole square is a square plus b square plus 2ab. Root 2 whole square plus root 3 whole square plus 2 into root 2 into root 3 equals to a by b whole square, a square by b square. Now here square root square cancel, then we remains with 2 plus 3 plus 2 into root 2 into root 3 root 6 equals to a square by b square. 2 plus 3 5 plus 2 into root 6 2 root 6 is equals to a square by b square. Now if you observe this step clearly, this is exactly same as the previous question. So we know how to solve from here onwards. So let us go with simply then 5 take to the right side, then it becomes minus 5. So 2 root 6 is equals to a square by b square plus 5 becomes minus 5. This 5 also can be written as 5 by 1. So here 2 root 6 as it is equals to, I am going with the cross multiplication process, b square into 1 b square, a square into 1 a square minus 5 into b square 5b square. In the next step, I am going to take this 2 also to the right side. Root 6 is equals to a square minus 5b square divided by 2b square. So from here onwards, we know very well how to write the sentence. That is, as a comma b are integers, RHS is rational, but LHS is an irrational. This contradiction has arisen due to our wrong assumption. So the given question is an irrational number.